So apart from Michaelis-Menten kinetics, let's have a look at other kinetics. So one of the examples is the Lineweaver-Burk plot kinetics. Lineweaver-Burk plot, okay? So Lineweaver-Burk plot ni dia adalah double reciprocal plot from Michaelis-Menten. You terbalikkan saja. Sebab kalau Michaelis-Menten is dia punya apa tu model dia begini. Apa Vmax darab concentration of substrate divide by Km plus concentration of substrate kan. So you terbalikkan saja 1 over V kemudian Km plus concentration of substrate divide by Vmax times substrate ni. So you akan dapat this equation kalau you terbalikkan Michaelis-Menten equation tu. Jadi bila plot yang mana kalau ada data of product rate versus 1 over substrate concentration, okay, so maksudnya 1 over product rate versus 1 over substrate concentration, so dapat the straight line here. So bermakna dia punya, this is the apa tu, kecerunan, what we call that, apa tu, okay, and then the yang ini adalah nilai 1 over Vmax dia. Alright, so this is the Lineweaver-Burk plot. Okay, Eadie-Hofstee plot pula, dia ada lain sikit, which is it is a plot of product rate versus product rate divided by substrate concentration. So kalau kita plotkan dia, kita akan dapat intercept as the Vm and the slope would be the negative Km. So this is the Eadie-Hofstee plot. So the Haynes-Wolff plot is actually the plot of substrate concentration divided by product rate versus the substrate concentration. So bila plotkan, kita akan dapat the slope to be this one, 1 over Vm, and this is the intercept. Okay, this is the intercept. So this is Haynes-Wolff plot. Okay, kalau Michaelis-Menten kinetics, when you integrate the Michaelis-Menten kinetic, you akan dapat equation, this equation, and this equation somehow it reflects the batch enzymatic reaction. Kemudian kalau rearrange and then you plot 1 over T times ln substrate initial concentration versus substrate concentration versus substrate initial concentration minus substrate concentration over T, you akan dapat the slope to be 1 over negative 1 over Km dan intercept dia adalah Vm over Km. Okay, this is some kind of the interpretation of Km and Vm. Previously, I have told you that Km is the dissociation constant of ES complex, and it is it is rate parameters, and it is expected to change with temperature and also pH. So Vm is the same as reaction rate, so it could have this unit. And then K2, rate constant 2, rate constant at the second step, reflects units of initial enzyme concentration. If the enzyme is highly purified, it may be possible to express the enzyme initial concentration in mole per liter or gram per liter, and therefore the rate constant would be K2 would be 1 over time. If the enzyme is crude, its concentration is in units. Okay, we don't know the real units, the real for enzyme if it is crude, which is it is not purified. So a unit is the amount of enzyme that gives a predetermined amount of catalytic activity under specific conditions. Okay, if Vm which is reaction rate for enzyme catalysis, is millimole per liter per minute, therefore the enzyme concentration initial is units per ml, then K2 should be millimole per unit per minute. Specific activity is the number of units of activity per amount of total protein.